Hello, I'm Vinay, and in this big data assignment, we're gonna show how we use PySpark for basic data modeling purposes. In this, we are using k-means clustering algorithm. K-means clustering is used to distribute our observations across a cluster. Now let's get on with the code. I've imported various libraries here like k-means from PySpark MLlib, that is machine learning library, and we're going to use various methods from that particular library further in the code. And I've imported things like Spark context, which is basically used for creating an RDD. Next, what I'm doing is I've loaded the iris data set. The iris data set can be found in UC Berkeley database and can be downloaded from there. Next, I'm gonna pass the data. What I'm doing here is I'm using the map function and to split the data set, which is a CSV file, and which is comma separated. And so I've just ran the output for the same here. As we can see, the data has been loaded successfully. So iris data set has as we can see, has various parameters, and depending on these parameters, the flower iris has been classified as different classes in the data set. Next, what I'm going to do is I'm going to take only the parameters which can be used to predict the class. So I'm assigning the variable called params only, and I'm using the map function over here to take only the parameters which is necessary for our prediction purposes. Next, I've just run the same parameter for the first 5 data points, as we can see here, first 5 arrays, as we can see here, just to see whether the parameters which we chose have been loaded properly. Next, what we're going to do is we're going to evaluate clustering by computing within the set sum of square errors. What we do here is we identify the within set sum of square errors and use that to group data points into different clusters. This is basically done in a loop, as it's shown here. We are running an iteration. We can stop this iteration when the maximum number of iterations has reached, or when the change within the clusters of sum of square errors is below the particular threshold value, or it's reached the local optimum. As we can see, as the number of iterations are increasing, the sum of squared error are decreasing, which shows that as the clusters in the k-means increase, the sum of squared errors also decreases. Now the sum of squared errors have reduced after each iteration, as shown here. And it has reached a point until it has reached a local optimum here, and this is how we know that we have achieved k-means clustering. And this is the assignment. Thank you very much.